Good morning. It's Sunday, March 15th, and you're looking at a live view of Falcon 9 as it awaits its 9:23 a.m. Eastern launch from Pad 39A at Kennedy Space Center in Florida. Hello from SpaceX headquarters in Hawthorne, California. My name is Jesse Anderson, and I'm a lead manufacturing engineer here at SpaceX. You're watching a live webcast for our 6th Starlink mission and our 6th mission overall this year in 2020. For those of you who aren't familiar, Starlink is a constellation of satellites that can provide high-speed, low-latency internet all over the globe, particularly in remote or rural areas where connectivity is limited or completely unavailable. Today's mission will also be the first time we are flying a booster for the 5th time. Most recently, this booster flew on our 2nd Starlink mission back in November. In fact, the first missions of 2020 were also carried out by flight-proven Falcon 9s. Just like our first stages, we are also starting to reuse our fairings. Today we are flying a reused fairing which previously flew on our first Starlink mission. We'll also get a brief update on our Starship program and some of the latest developments that production line in Boca Chica, Texas. With that, all systems are go for an on-time liftoff this morning.
Hello, my name is Michael Andrews and I'm a supply chain supervisor here at SpaceX. You're looking at a live view of our Falcon 9 rocket, our 70-meter, 2-stage, liquid-fueled launch vehicle getting ready for liftoff from our 39A launch site at Florida's Kennedy Space Center. While we have some time, let's discuss the components of that vehicle. The bottom 2/3 of it is our first stage. It accelerates the vehicle through the Earth's atmosphere to the edge of space with the help of 9 Merlin engines. And today we'll be attempting to recover that first stage for our 5th time on our drone ship, Of Course I Still Love You. It's currently stationed about 350 nautical miles northeast of the Cape. And above that first stage is our second stage. It has a single Merlin engine known as our Merlin vacuum or MVAC engine, and it ignites after first stage separation. This second stage will carry our batch of 60 Starlink satellites to an altitude of about 440 kilometers above the Earth's surface. From there, they will use their individual propulsion systems to move up to their operational altitude over time of 550 kilometers. The Falcon 9 you see on the pad there has been loading propellants since T-minus 35 minutes. As a reminder, we use a hybrid mix of rocket-grade kerosene, known as RP1, and super-chilled liquid oxygen, known as LOX, to power the Falcon 9. Currently, our RP1 is nearly fully loaded on the first stage, that bottom 2/3 of the vehicle, and for our second stage, it's fully loaded with RP1. The LOX loading is underway on both stages still, and that will actually continue to be topped off until the last minute of our countdown. And at the very top of the rocket is our stack of 60 Starlink satellites. They're safely enclosed within the 17-foot diameter payload fairing. It's that pointed cone you see at the very top of the rocket. This protects the payload from aerothermal loads, heating, and any kind of contamination during ascent. Now, once we reach the vacuum of space, we no longer need those fairings, and we jettison those 2 halves as the second stage continues on its journey to orbit. As we have in the past, we'll be attempting to recover those 2 fairing pieces again with our 2 recovery ships, Miss Tree and Miss Chief. They're currently positioned in the North Atlantic Ocean off the coast of North Carolina. In terms of weather, we had some fog at Kennedy this morning. You can see it's pretty much all dissipated. Weather conditions are nominal both at ground and upper altitudes. The Air Force range is prepared to support today's mission. So with that, the vehicle, our satellites, weather, and range are all looking green for an on-time liftoff just a few minutes from now.
As I mentioned at the top of the webcast, today's launch will be the first 5th flight of a Falcon 9 booster. And if we land it successfully, it will mark the 51st recovery since we started landing our boosters back in December of 2015. Right now, our turnaround time to refurbish a booster for reflight is roughly 8 weeks. Long term, we hope to continue to drive that turnaround time down even further, with rocket launches looking more similar to commercial air travel where planes get basic checkouts, get refueled, and then head back out. Reusability is core to our mission here at SpaceX, which brings me to our efforts underway in Boca Chica, Texas. If you've been following our progress, you know SpaceX is currently building and testing its next-generation spacecraft called Starship. The site has changed dramatically in just a year as we build up our production line. The local team has executed a variety of tests designed to push the limits of the vehicle. Next up are a series of static fire and short flight tests with our serial number 3 test article, and longer flights with our serial number 4. But ramping up our Starship and Raptor production line is what matters most. The design goal for Starship is 3 flights per day on average, which equates to roughly 100 flights per year at greater than 100 tons per flight. This means every 10 ships would yield 1 megaton per year to orbit. This is a significant effort, and we are looking for highly skilled engineers and welders to help us make this a reality. If you're interested in joining the team, please take a look at spacex.com/careers.
We're currently only 6 minutes from liftoff. Falcon 9 is now moving into its final stages of the countdown. At T-minus 7 minutes, our engine chill process began. This is where we allow a small amount of that super chilled liquid oxygen to flow into the Merlin engine turbopumps prior to the full flow of LOX into the vehicle. This helps us avoid any kind of thermal shocks to our system. Liquid oxygen is also what's creating the white clouds you might see around Falcon 9. We continue to load that super chilled LOX into the stage until just before liftoff. And when that liquid oxygen comes into contact with the ambient air around it, it boils and creates the clouds surrounding the vehicle that you see on your screen. The cradle, or the arms that you see near the top of the vehicle, will begin to open around T-minus 4.5 minutes, followed by the transporter erector, retracting away from the rocket, starting around T-minus 4 minutes. This is only a couple degrees that it moves, so it may be visually imperceptible, but it's enough room for our Falcon 9 to clear the transporter erector during liftoff. The first and second stages are both nearly fully loaded with 1 million pounds of kerosene fuel and liquid oxygen. The first stage should finish prop loading at T-minus 3 minutes, and the second stage right behind it at T-minus 2 minutes. And at T-minus 60 seconds, be sure to listen for the call-out that Falcon 9 is in startup mode. This means that the rocket's autonomous internal flight computers have taken over the launch countdown, and we humans are no longer in the loop. The Starlink payload continues to be healthy. The Falcon 9 team is tracking no issues on the rocket at the moment. Weather's looking good, and the range is still green for launch. So with that, there's nothing left to do except listen in to the last few minutes of the terminal countdown. You can actually see those clamps up on the transport erector have begun to open. And if you watch closely, you can maybe even see it begin to retract.
Strong back lower started.
And the retracting process has just begun. If you watch it closely, behind that liquid oxygen that's boiling to regular oxygen.
Strong back lowers closed out.
Stage 1 LOX load closed out.
So RP1 loading and LOX loading on our first stage has completed. We're waiting for the LOX loading on our second stage to complete. And then after that, the startup mode call-out. T-minus 2 minutes to liftoff.
Stage 2 LOX load closed out.
Ground gas closeouts.
Falcon 9 to startup.
LDs go for launch.
T-minus 30 seconds. T-minus 15 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Ignition. Liftoff. Disregard. We have an abort.
Launch abort is running.
As you may have heard, we had an abort condition just prior to liftoff. We're going to listen to the nets, hopefully have more information and share it with you soon.
So launch abort on engine high power. As you just heard on our countdown nets, we had a condition regarding engine power that caused us to abort today's launch. Prior to that, the countdown was proceeding nominally, but keep in mind the purpose of the countdown is to help us catch potential issues prior to flight. There are 1,000 ways a launch can go wrong and only one way it can go right. Given that we are overly cautious on the ground, and if the team or the vehicle sees anything that just looks even slightly off, we'll stop the countdown. Overall, the vehicle appears to be in good health, but that will end our launch attempt for today. Please stay in touch with our social media and web platforms for that next launch opportunity. Hopefully you'll join us again for that next attempt. Until then, thanks for joining us today, and we'll see you next time.